I hope the screen is visible, right?
Yes, yes, yes.
Okay. Cool. So, hi everyone, and good morning, and welcome to another session on this series of blockchain and related topics that we're doing every Sunday. And on continuing with that, today's session is on something which we started in the last session, which was around cryptography, and where I mentioned different types of cryptographic mechanisms that we can leverage. The two of them being the symmetric and asymmetric. And today we would like to just continue with that, and we will see how symmetric cryptography works and what asymmetric cryptography is. Today, I won't be dwelling a lot on how these things work in terms of theory, but I would like to just give you some hands-on by going through some code bases that I've just written for this demo, which will basically be for a small console application, which will actually showcase you the process of an asymmetric encryption and decryption compared to a symmetric encryption and decryption. So that is what we intend on doing this morning. So like I mentioned last time as well, so cryptography can be divided into two different branches, one being the symmetric and the other being the asymmetric. On a very high level, a symmetric cryptography is where there is one single key which is used to encrypt the data, which is converting the data from your plain text to the ciphertext. And then that same key is again reused, and that is used for bringing that back from the ciphertext to the plain text format. So in this symmetric key encryption, the message is encrypted. It is encrypted using the same key. The key that we talk about, this can be of different sizes depending on which algorithm you're using. So any sort of so in symmetric also and in asymmetric also, we have different algorithms also which we can leverage. Like for example, in symmetric we have certain encryption algorithms like AES, which is advanced encryption standard. Then we have DES, which is data encryption standard. Then what we are going to be using today as a demo is something which is called triple DES, which means that the data encryption standard algorithm, it is implemented on the plain text three times, so it becomes 3DES. But the overall understanding and logic of the symmetric encryption pretty much remains the same in terms of that it uses one single key for the encryption and the decryption process both. What are the merits and demerits of this? So the merit of this is that it is easier to implement. You generate a key and you use that key on both sides to encrypt and decrypt the messages. And overall, the implementation in terms of logic is quite simple. The downside of it is that it requires a safe method or a safe mechanism or a communication channel for you to send the you send or transfer the key to the receiving party. Because if you are the sender and you encrypt the message using a certain key, for the receiver to decrypt that, he will require that same key to be available as well. So if you are sending it on a channel or any sort of medium where the data, encrypted data, is being transferred, if you are sending the key along with it, it doesn't serve the purpose. Which means that if someone is seeing intercepts the communication, they intercept the encrypted data as well as the key, and they can decrypt the same on their end as well. So that is something which is of a concern in here. But the way these are used is that it is generally used to maybe store your data in an encrypted format on your own local machine, or if the key can be safely transferred to the receiving party in a separate channel, which is not a public channel. It can be transferred through a different channel or route that can basically allow this demerit to be pretty much negated. There is another approach which usually is used, is that we encrypt our data using a symmetric mechanism, and when we transfer the data is transferred in the AES or the symmetric encrypted format, but the key is again encrypted using a asymmetric encryption mechanism. The private key remains with the receiver, the public key remains with the sender. And what they do is that we encrypt the data first with a symmetric algorithm, and then the key again is encrypted using an asymmetric algorithm, and where they are sent together. So in between, even if the key and the data are intercepted, the key in itself is also encrypted, which cannot be decrypted until you have the private key, which is only available with the receiver. So that's how in a even a public network, or even a non-secure channel as well, if you want, you can have different layers of these encryption algorithms implemented to have these pretty much architected well. So this is the first sort of encryption mechanism, which is symmetric cryptography, which requires one single key to encrypt and one that same key to decrypt as well. And the examples of would, as I mentioned, is like AES, DES, triple DES, and those sort of mechanisms. The other mechanism that we would like to talk about is the asymmetric, which is the other one wherein you have a key pair, and one key is used to encrypt the data, the other key is used to decrypt the data. So the key pair that we generate, it is usually called as a public private key pair. The public key is something which is used to encrypt, and the private key is something which is used to decrypt. So the way it is used in a practical solution is that you as a user, or you as a user generate your key pair. You uh, safely keep your private key with yourself. You do not share it with anyone, but you share your public key with the sender, who from whom the data is gonna come. So the person who is sending you the data, they basically encrypt the data using the public key that you have shared. They encrypt the data using that, and then what they do is they basically send the encrypted data using the public key. And when the encrypted data comes to you, you have the private key with yourself, and you can use that to decrypt the data. And there is very it basically eliminates the problem that we had with symmetric in terms of communicating or sharing the uh, encryption key as well during the transmission. So here the private key always resides with the receiver who wants to decrypt the information. So in a way, what happens is that if two people want to communicate something in an encrypted channel, I would generate my own public private key pair, and the other person would also generate his or her own private public key pair. And what we will do is we will share our public keys with each other. And whenever I need to send something, I can encrypt it using the public key that the other person has given me. I encrypt the data, send it to him or her. On their side, they decrypt the data using their private key. The same thing happens whenever they want to send anything back to me. They encrypt it using my public key that I had shared, and I decrypt it using the private key that I possess. So that is exactly how this entire thing basically works out. And it is comparatively more secure than the symmetric key encryption technology. But obviously, because it requires these two key pairs, one for encryption, one for decryption, in terms of performance, it is a bit slower when you compare it with a symmetric encryption algorithm in terms of encryption and decryption. Also, uh, the complexity of this, basically managing two keys for encryption and decryption, it is a bit complex than what you do in a symmetric one, wherein it is much simpler. uh, some of the examples that we can talk about in terms of the encryption algorithms that we are talking about. So in encryption algorithms, when we talk about for asymmetric, one of the major algorithms that we usually use is called RSA algorithm. So RSA is a very popular algorithm that is mostly used when we do these sort of asymmetric encryption and decryptions, and that is what we are going to use in the demo as well today. The other examples could be like the ECDSA, which is something which we are going to cover in future sessions, which is the algorithm which is used in the blockchains for creating those public private key pairs. So it is based on RSA, but it's a separate algorithm implementation, which is called ECDSA, which is elliptical curve data secure algorithm. So we will be using that in a future session. But today I would like to show you something in terms of codes, wherein how this can be implemented. So this small console application I've just created, which is basically going to implement both the symmetric and the asymmetric encryption, and we will see how they are basically working out in terms of uh, generating a plain text information, or getting a plain text information from a user and generating the keys, encrypting the data, and then again decrypting it back from the encrypted information. So the first, I've just written all the code in this one single application, but I've just commented out the asymmetric one first. I would just like to show the show first the symmetric one, how it is working out, and then we will look at the asymmetric one as well. For the symmetric algorithm or the symmetric encryption, I have used a triple DES encryption, which is a modification of the DES algorithm, wherein, as I mentioned, the same DES algorithm is used, but it is done thrice on, or the DES algorithm is applied to, thrice to the same data, to get a much more secure encrypted data. So I'll just quickly go through the code bases right now. So what we can see over here is, first and foremost, what I've done is I've created a few helper classes for me. Like one helper class is called the symmetric helper class, wherein all the functions and the functionalities for the symmetric algorithm have been implemented. So in here, if I go, what I've done is I've created three functions. One is a generation of encryption key, one is encrypt, and one is decrypt. These are quite simple in terms of we have implemented in here. The first one is a generation of an encryption key. For the triple DES encryption algorithm, the key size that we are looking at, it is a key size of 24 characters. So a 24 character key is required for the triple DES encryption as an encryption key. So what I've done over here is I've created a small function which generates a random string of information of 24 characters, which is generated using capital alphabets, uppercase alphabets, lowercase alphabets, digits, and some special characters. So I have created a string of this these characters that are possible, which will be picked up in this particular logic to generate the key that we are looking at. And then what I've done is I've created a small character array, which is of 24 characters, which is the required size for the key of triple DES. And then what I do is I basically generate a random number, and this random number basically allows me to continuously generate new random variables or values or keys from this. And then what I do is I basically loop when this particular I use a loop which is about string characters dot length, which is actually 24, which means I run this loop for 24 times, and every time what I do is I pick the string, and from there I use the random function to use the next random character, any random character from this, and I just keep on picking one character at a time from here, any random character, and from there it is done 24 times. And what I do is I basically create a 24 character string, which is going to be serving as the encryption key from my triple DES encryption algorithm. After that, once this is done, I pretty much return the key, which is use data. For the encrypt and the decrypt method, what I use is I accept the input, which is a string, which in case of the encryption function is the plain text information. And I also receive the key, which is used for the encryption. And since it's the in symmetric, it is the same key is going to be used for the encryption, decryption both. So if you look at the function declaration, you will see that the encrypt and decrypt both basically accept the input and the keys. But it is the inner function that we have, wherein so I must tell you that in the language that I'm using is C sharp, and in C sharp or any other programming language that you use like Java or Python, everyone has their own implementation of these algorithms already pre-built as libraries. You do not have to create the or write the entire logic of the encryption and decryption yourselves. No, you just have to initialize the classes and create an object of those, and then based on your requirements, you just configure the object with the certain parameters that are required. Like for example, when I want to encrypt it, I create the triple DES object, I specify the key which is received, and it needs to be converted into bytes. Then there is a mode which is called which has been used as ECB, which is called as an electronic code book. And then the padding, which can be different, like PKCS7 or something, wherein every algorithm has different padding mechanisms, wherein the characters that are generated, they have a certain padding in binary when they are generated. So this is the standard that is usually used in triple DES, which is PKCS7. And after that, you basically create an encryptor object, and then you use the final function, which is transform final block, and it basically generates your encrypted information into a results array of byte. And then what I do is I just convert that array of bytes into a base 64 string, and then that becomes my encrypted data. For decryption, what I do is I receive the input, which is the encrypted string converted to base 64. And first conversion that I need to do is I need to get the information from the base 64 string back to the byte array, which the encryption actually generated. And then once the uh, array is generated, I again initialize the triple DES logic, the object, uh, initialize it with the key, the mode, the padding, and again create the decryptor, and then again use that as into this transform final block. And sorry, in this, when you look at this, the only difference that you would see is that when we are encrypting, the triple DES dot create encryptor is called, while when we are decrypting, the triple DES dot create decryptor function is called, which is basically doing all the decryption for you. In here as well, when you decrypt the data, the decrypted information is also in a byte array, and you need to convert it into a string, which I have done here, which is UTF encoding dot get string, and you pass in the byte array and you get the string back. So this basically does your decryption. So if I go back to my code, and if we look at this implementation from a higher level, what we are doing is, the first step is we are generating the encryption key. Then I'm just console right lining this, wherein I want to see what the encryption key is. Then I am asking the user to enter a text to encrypt, which is read using this console.readline and then stored into this variable which is called plain text. Then I print the plain text information before encryption. Then I call my encrypt function, pass the plain text and the encryption key, and get my cipher text, which is the encrypted data. Then I print out the cipher information, which is the encrypted data. Then I again decrypt the cipher with the encryption key, same encryption key, because it's a symmetric encryption mechanism. And when we do it, we receive the decrypted text, and finally we print out the decrypted text again. So in a nutshell, what should happen is I generate a key, I take the information or the text from user, encrypt it, and show the encrypted information, and then again decrypt it, just for this particular demo. So what I'll do is I'll just quickly run this code right now and show you what happens in here. It's a console program, so you'll see a black screen come up any moment now. So in here it is. So right now I've just set up a debug point just to show you what's happening at these levels. So let me just quickly move this away. So if I just step into this and click on continue, you will see that encryption key that was generated is this value, which is a combination of all the different characters that we had put in that generate key algorithm. Now it is asking me to enter a text to encrypt. So we will write here like something like blockchain is fun or something, and then I'll just hit enter. Now you will see that the message which says plain text before encryption is blockchain is fun, which is the plain text information that I entered. Then the encrypted text is this, which is the value that got encrypted and base 64 encoded. So this is the encrypted data for this particular text that we entered. And then after decryption, it again got back to what we entered. So this is what's happening in here. So if I again run this and I show you step by step what's happening in a debug mode, you will see what's happening in here. So we first call the generate key, and it gave us a generate key, which is this, which is a new encryption key again. So it got generated. Then I printed out the encryption key, which is in here. You'll see this got the encryption key got printed. Then I asked the user to enter a text. It will wait for me to enter something. I will put in A, B, C, D, E, F, hit enter, go to the next step. In here, we will print the plain text first. The plain text information got printed. Then it is encrypting the plain text with the encryption key. And as soon as we do that, the cipher information is generated, which is this. This is the base64 encoded value that we basically got after encrypting the data. Now I print that into screen. You get this information. Now, if you look at the decryption information, when we are putting it, we are putting this encrypted text, which is the cipher information and the same encryption key. I pass it on, and now I get a decrypted information, which is A, B, C, D, E, F, which was the plain text information that we added. And then it just prints that out, and the program execution stops. So this is what a simple implementation of symmetric algorithm looks like. Now what I will do is I'll just comment this portion out, which is the symmetric one, and bring this portion of the code back, which is the asymmetric one. So similar to what I did for the symmetric, I have also created a similar helper function in the for the asymmetric as well. But in here, the encrypt and the decrypt function have just been created, wherein for encrypt you pass in a string which needs to be encrypted, and you pass in the public key in a string format, and the public key is then used to encrypt the data. How do you do that? You use something which is called as an RSA crypto service provider package. So this RSA crypto service provider package is part of the system.security.cryptography library, which Microsoft C# has. So this includes this RSA algorithm, and this is the library that is used to do the RSA algorithm implementation. So in here, to encrypt the data, what needs to be done is you need to pass in the public key. You first create an object of the crypto service provider, and there you get this public key, which is in form of an XML data. So from there, you read the XML information and you initialize this public key into the RSA object. From there, next what I do is I convert my input string, which is the plain text information, into a byte array. And then I use the RSA.encrypt function to encrypt the byte array. And basically then I just have to pass in this value, and it gets encrypted, and you get a byte array of the encrypted information. I convert that encrypted byte array into a base64 string and return it back as the encrypted text. For the decryption, what I do is I receive the encrypted text, which is the cipher text, and the private key of the key pair. Exact same thing happens here as well. The RSA crypto service provider object is created. You initialize the private key into that object. You convert the cipher text, which is already in base64. You convert that back into a byte array, and then you just call in the RSA.decrypt function with this particular byte array, which is the cipher text byte array. And as soon as you do that, you get a byte array back, which is your decrypted byte array. And for the user to make sense out of it, we just convert that byte text back to a string format and return it back to our main calling function. So if I go back to my main function, in here, this all has been done. But before that, like what we did in the symmetric encryption, we generated our own keys. For the RSA key pair to work, what has to be done is you just basically create an object of this, the RSA crypto service provider. As soon as you create an object of this, corresponding public and private key automatically gets generated. But if I want to keep them segregated, it is part of this object itself. But if I want to keep them in different variables, I need to extract those keys which are in XML format from that RSA object. So what I have done here is I have kept two strings. One is the public key and one is the private key. For the public key, what I do is RSA.toXML string, and I just say false. When you write this, you receive the public key. So RSA.toXML string with a parameter of false returns the public key in an XML format, and RSA.toXML string with a true returns the private key in an XML format. So now after this, I receive the public key and the private key in two separate string variables. Then what I do, similar to the previous example, I ask the person user to enter any text which needs to be encrypted. I receive that into this plain text variable, print the plain text variable before encryption. Then I use my asymmetric helper encrypt function, which is the one which we just saw. And then I pass in the plain text information with the public key. Remember that in asymmetric, to encrypt the data, you need to use the public key. So I pass in the plain text and I pass in the public key, and it encrypts the data and gives me back the ciphertext. Now I print the ciphertext just for reference. Then to decrypt the data, I again call back the decrypt function in the helper function that I created with the cipher information, with the ciphertext, which is the encrypted data. And now I pass in the private key, not the public key, because if I pass the public key, it won't work. I have to pass in the private key of the key pair from which it was encrypted in the first hand. So I pass in that private key, and it does the job at the helper level function, and then gives me back the string, which is the decrypted information. And this is how it will all work out. So let's just start with it again, and let's just see what happens in here. So in terms of the overall working, you won't see a lot of difference. It will take information like A, B, C, D, E, F. If I put in, it will print me the information which is before encryption, and it will show me the encrypted text, which is this one. And then it will again decrypt the data and basically show me what the plain text information is after decryption. But there is some major changes in here. So what I would also like to show is, I would like to show you what those keys are in XML format. So let's say that I want to print the public key. And I also want to print the private key. Just for reference, we just want to see which information got generated with these variables. So let's just see what happens in here. And let's see. So if you see, this is the public key that got generated. It is in form of an XML. And this is the private key that got generated, which is also in form of an XML. And these are the information that we are trying to use. So if I just again put in A, B, C, D, E, F, so it basically gets the information, encrypts it using the public key, and gets this cipher information, and then again decrypts that to find this. Now, apart from how the keys look or how the keys are in both these encryption algorithms, what I would also like to show you is the difference in the encrypted data when two different algorithms are used for them. So if I encrypt the same information in your symmetric data as well, and in symmetric algorithm and in asymmetric, is there a difference in the encrypted data that we look at? So we will quickly have a look at it. It of course would be different, because they are absolutely different algorithms, and the encryption algorithm that I'm or the encrypted text that the text that I'm going to use to encrypt is going to be exactly same, but you are still gonna see that it's gonna generate different encrypted data. So this is my plain text that I'm gonna encrypt first using symmetric key, and then again it's gonna ask me for the text which is for the asymmetric, and again I'm gonna do the same. So in here, if you look at the first information, this is the encrypted text or the encrypted information that we saw in form of in the symmetric encryption algorithm. But the same data when encrypted using a asymmetric algorithm, it generates a quite a larger set of uh, encrypted data that you have. So for this 6-character information as well, the amount of data that it generates for the encrypted information, it is quite large. So this is one of the other consideration that you also have to make, that while doing the transfer of information, the encrypted information, the payload that is going to get generated in the symmetric and compared to the asymmetric, the symmetric data payload, encrypted information payload, is going to be very small compared to the asymmetric one. The asymmetric one usually is larger in size compared to the symmetric one for the same information that you are trying to encrypt. So these are the two different sets of algorithms or different mechanisms that I just wanted to show you, and that was pretty much in my agenda for today. And if there is any question, if there is anything that you would like to ask me, please feel free.
Okay.
Right.
Yeah, no, thank you, Vijay. I think it was a good session. It was a very clear session.
Okay.
I hope there are other people. Let's wait if they have a question. Else we are good.
Sure.
Cool.
It's not.
All right. So
Yeah.
maybe what we are planning to take in the next session, we can give a brief rundown and maybe summarize.
For the next session, we have the ECDSA algorithm. So it is an asymmetric algorithm as well, like what we saw in RSA, but it is specifically used in the blockchain technologies, wherein the public key and the private key that we talk about pretty often while working with blockchain and different sets of that stack. Uh, it is always those public and private keys that we talk about, and the ECDSA is the algorithm that pretty much works at the back of it, which allows you to create these key pairs and also signing, hashing. These all terms pretty much are synonymous to that particular algorithm. We would like to just go through that particular piece of algorithm and see how it works out.
All right. Thank you.
All right.
Thanks.
Thank you.
Thank you.
Thanks everyone.
Thanks.
Thanks for joining. Bye bye.
Thanks, Abhijit. Thanks a lot. Thanks, Amitesh.